Hey Thinksters, what's up? It's Adam, and in today's video I'm going to be talking to you about how to create 3D plots in Matplotlib. If you're tired with the same old 2D plots, you want to take your plots to the next level, look no further. It is time to learn how to make 3D plots. So of course, as with all Matplotlib plots, at the start we're going to need, or at the start of your script, not necessarily at the start of every plot, import matplotlib.pyplot as plt, the standard import, and then of course to display a plot, calling plt.show right at the end. There are 4 things you need for a 3D plot. So the first thing is to import the axis 3D object. That is the axis that looks 3D. It seems a bit self-explanatory, but I'll explain a bit more in a second. You then need to initialize your figure and your axis 3D objects. You need some 3D data, of course, and then you plot it using axis notation and all the standard function calls you know and love. So let's just dive right into an example. Standard import, matplotlib.pyplot as plt. So the 3D axis is we do from mpl underscore toolkits.mplot3d import axis 3D. In older versions of Matplotlib, pardon me, you had to use like capital A and capital D, but that doesn't matter anymore. We're going to set up our figure and 3D axis. So first figure using plt.figure and storing that as fig, and then fig.add subplot 111, which is a subplot with 1 row and 1 column, and it is selecting the first one, and in this case the only one. And then we are going to project this axis. This is a new keyword that becomes available once we import axis 3D. So we're going to say projection equals 3D, and unsurprisingly, that makes our axis 3D. Now we just need to get some 3D data. I just made up these numbers, these X, Y, and Z lists. Note that these are capital X, Y, and Z, and we will be using these throughout the article. So I recommend, like, if you are going to follow along, copy and paste these. And then finally, we just do ax.plot, because we're going to be calling with respect to this axis. Pass X, Y, and Z, plt.show, and here we go. We have a 3D plot. Incredible. So you've just done your first one. You may be thinking it looks a bit odd, it's a bit difficult, and I'm actually going to agree with you there, and I'll show you some ways we can make it look a bit better now. So let's dive into a more detailed example. So first off, if you are used to plotting with figure and axis notation, then making 3D plots in Matplotlib is pretty much identical to creating 2D ones. If you aren't comfortable with that though, I really recommend you check out this article. So I wrote this article all about creating subplots, and this link takes you to the bit explaining what figures and axes actually are. In a very quick summary though, the figure is this white space around the box. Wait, let me turn my, there we go, hopefully that's a bit less orange now. Is the white space around the box, and then the axis is the thing that you plot on. So it's actually written AXES, like plural of axis, and that makes sense because it is a combination in 2D of an X and of an X axis and a Y axis, but here it's a combination of an X, Y, and Z axis. So yes, you need to set up your figure, and you can do that in the very standard way. plt.figure just creates a figure with standard dimensions, and we save that as fig because we need that to use the fig.add subplot method. So we can actually add multiple subplots this way. That is explained in this article as well. And then I've explained what 111 is, and then from then on, once you've imported the 3D axis, once you've set up your figure and you've set up your 3D axis, like axis object, everything else is pretty much the same. So all the functions you know and love, like like plot and scatter, they all accept the same keyword arguments. You just need to call them with respect to an axis rather than plt dot. Though, to be honest, you could actually get away. So let's see. So this is our plot here. You could actually get away with doing plt.plot here if you really wanted to, because when you're using pyplot, you're actually plotting with respect to like the most recent axis. And since there's only one axis here, you can do PLT if you want, but I would say it's bad Matplotlib form to not do that. Plus, once you learn to plot using figures and axis, you'll realize that it's absolutely awesome, and it just gives you way more control, and there's some nice little functions, and you'll see some of them later on that make things quicker and easier. So really, the main difference is that your functions like plot, scatter, bar chart, well, anything really, they all accept 3 positional arguments, so x, y, and z now. I know that in some ways, like 3D plots are more natural for us since we live in a 3D world, but because we're so used to doing 2D plots all the time, it can be a bit confusing. I know I found them very confusing when I first started out. So one thing that's really helpful is the Matplotlib the Matplotlib notebook magic command. So if you just type this at the top of your Jupyter notebook, like %matplotlib notebook, it will change the back end, and all of your plots will now be displayed in this interactive figure. So to save me from having to restart the kernel, I'll just show you what it looks like in here. So this is just a terminal window. I'm running IPython in here. And now we'll just copy and paste this in. We'll just copy paste all this in. And you'll see that it is displayed in this window, and this window will just appear in your Jupyter notebook in line here where the code comes out. And you can see that we can click and drag and move it around, and this is such an awesome feature, as you can really start to get an understanding of what the data looks like by really clicking and moving around. And you'll see that the axis labels all move. It's a bit confusing, of course, because we haven't labeled the axis yet, but we'll get to that in due course. One thing that's really helpful, so all these buttons are a bit strange. They don't really do anything. One thing to note is that if you, if you right click and then move, you can zoom in and out. I'm on a Mac, so I have to click down with 2 fingers and then move in and out, and then you can zoom. And if you wanted to save this, so you just click this save button and it would save the figure looking exactly like this, and then you can move it around a bit and then click save again. You can get it from a different angle. So this is really, really, really helpful. And I recommend, if you are doing like real data analysis with 3D plots, you should be moving it around, just because it just helps you understand like what's going on so much better, and you can see relationships much better. Like, it's hard to kind of tell what it looks like but when you move it out like this, you can see, oh, they're all kind of joined up in a line nicely here. And if we look down from the top, you see there's no crossover, but there's quite a lot of crossover when we look at that. Cool. So let's get back to it. Let's just dive into another line plot example, because this one is nice, but I just made it up and it doesn't really showcase the power of 3D plots, I would say. So we're going to make a more complex one, so bear with me here. I believe that we can get through it though. So we are going to, it's going to end up looking like this, like a spring and a circle. And these are all created with sine and cos functions. If you remember your high school maths, you remember that like x squared plus y squared equals 1 is the formula of a circle. And you can use sine and cos to do that as well. So standard imports up here: matplotlib.pyplots plt, numpy is mp, npl toolkits.mplot3d as import. So from that, import axis 3D. And we're going to just set up our figure and axis the same way. We'll almost always be setting up that way, so I won't explain it anymore. And now, this is where it gets interesting. So we want to, well, basically we create this variable theta using np.linspace. If you don't know what that function is, check out my article here. This is actually the first article I ever wrote for Thinkster, explaining what np.linspace does. But in short, so here we've passed -12, 12, and 200, and that means it creates a list of numbers from -12 to 12 inclusive, and they are all equally spaced out, and the total number of elements in the list is 200. So there's 200 equally spaced out numbers. And why is it lin space? Well, that if they're equally spaced out, there is a linear difference between each of them, rather than a squared difference between numbers, which would be like, for example, 1, and then 1 squared is 1, the difference between the first number, and then the difference between the second number and the third number could be 4, because that's like 2 squared, or something like that, basically. Or the distance squared, basically. I think that makes sense. So yeah, we create this list, and then we apply sine to that list, and then we apply cos to that list to get a range of sine and cos values when applied to those numbers. And as you know, sine and cos, they're the waves, so they just go on indefinitely, and so that's why there's all this kind of up and down motion. And then finally, we need to create a z space, so that is the vertical axis here, and it has to be the same length as our x and y, and since x and y are made up of sine theta, we need to look at theta, and theta is 200 elements in length, so we need z to be 200 elements in length. And then we just pass all of them to plot, call show, and this is what we get. So you can see that if we change the z here, so we're going to change it, so currently it goes from 2 to -2. If we change it from -10 to 2, you'll see that it goes from -10 to 2, but you'll also see that the difference, like it actually looks like the exact same plot if you didn't check the axis labels. And that's because they are all linearly spaced out, and so this plot itself won't look different. Of course it would look different though if the z-axis labels were scaled differently. But we'll move this back to -2 and 2. Another thing to bear in mind is that if you choose a smaller number of values for np.linspace, then you will get this won't be as smooth. So the reason we choose such a high number is to make it look like it's a continuous line. But of course, for all line plots, like they are just points being joined up together, like this one. So if we move this down just to 20, you'll see that it's very jagged here. Or if we change it to something like 25, then it's jagged and in a different way. But again, let's move these back to 200. Lovely. Cool. Right, let's move on to scatterplot. But before we do, if this didn't make sense to you, I would recommend you re-watch this part of the video and also go through it line by line. Have a play with these functions and these variables and just see what happens when you change them. Because that is how I learned, and I really think it's the best way if you just fiddle around and see, because it can be a bit confusing, like applying sine to these lists and all that kind of thing. So yeah, right, let's move on to a scatterplot. So one thing I found that was really cool is from this YouTube video, is if you sample a normal distribution and then create a 3D plot from it, you actually get a ball of points, and the majority of the points are focused around the center, and they get less and less frequent the further around you go. So that's pretty cool. So this is what it looks like. And to create that, we're going to import Python's random module, set the seed to 1. That means you can, if we run this, we'll get the exact same results every single time, and you will get the exact same result as me if you run this code. And then I'm going to create I'm going to sample a normal distribution with mean 1 and standard deviation 1. I'm going to do that 400 times to create, and using a list comprehension. So note here that the variable is an underscore, and you can just use that if you don't need to give a variable name. So this basically just means like call this function 400 times. And then that is our variable x, and it's also going to be our variable y and z. And of course, because a normal distribution is a random variable probability distribution, it's going to give us different values every single time we call it. So x, y, and z will be different. Then we just set up our figure and axis as normal and call ax.scatter, passing x, y, and z, and this is what we got. I think this would be a cool example to, I'm going to copy paste all of this into the IPython terminal. And this is what we get. I think it's quite nice to move around and see the different plots where they're all located. Yeah, so it's always nice to have a little play around. One thing, let's move on to this example now. So actually, I use this example in the article just because it was a bit easier to show. But I think let's just use this normal distribution article. So you'll see that some of the points are different shades. So let's look at this point right here. Keep your eyes focused on here as I rotate it around. You see that it's quite a dark point. Oh, we kind of lost it a bit. Still over here on the edge, quite dark. But then as we move it away, it starts to become light. And this one is now dark, but if we turn it around 180 degrees, it's now lighter. Oh, sorry, that wasn't very good. And this indicates like the depth. Actually, I think it would be a good idea to use this code. So let's just copy paste this in. So this is just plotting the X, Y, and Z variables up here, from here, that I said before. So we'll plot these, paste this in. Cool. And you'll see that the ones that are at the front, it's now dark. And if they are at the back, they are translucent. So that's a nice thing that it shows you, so you can even get the depth with these plots. Matplotlib is quite clever there. Okay, moving on. Rotation, I've already showed you how to do that, so we won't dive into that particular topic here. Let's dive into some adjustments you can make to these plots. So one of the first ones you'll want to do is setting an axis label. So it's identical for 2D plots, but now there is a third axis, the z-axis, that you can label. So there are two options. You can use the ax.set x label, set y label, z label methods, or you can use my favorite, the ax.set method. This is one reason why using figure and axis notation is amazing. And you can just pass the keyword arguments, x label, y label, and z label, to set all of them. But you can set other things as well. You can set color, you can set marker length, you can set so you can set like title, you can do things with the X, you can do things with the ticks, you can do so much. So it's really, really useful function. So here is an example, just the same plot that I've just shown you, but we're using method 1. Takes up 3 lines of code, really boring to type those lines of code out. Some of you might get bored and actually copy paste, which is a cardinal sin of coding. You shouldn't be copy pasting. But it does work x-axis, y-axis, and z-axis, but they are a bit hard to see, and that's because the defaults for 3D plots aren't ideal. But don't worry, we can fix that we can manually set the figure size in a second. And now I'm going to show you the big advantage of using the set method. So first off, in our fig call, we're going to do plt.figure and fig size equals 8.6. So that creates a figure that is 8 inches wide and 6 inches tall. It's not pixels, it's inches. Don't pass like 800, 600. Your computer's probably going to crash. Axis setup's the same. ax.scatter's the same. But now, lo and behold, method 2. ax.set, x label is x-axis, y label is that, z label is that. It's just beautiful. Beautiful. And then, so now you'll see that the figure is slightly bigger. So it's now 8x6. And so you can read all the axis labels nicely. And also, it only took us 1 line of code to do this. And if we wanted to add a title, let's call it my title, we can. Awesome. It just gets added in straight away. We don't have to type in like set title, which of course we could. Now, these may be different, so I'm just going to rerun this one just to make sure X, Y, and Z are reset. Cool. Okay, moving on to adding. Oh yeah, so in general, if there is an ax.set _ something method, it can be written as ax.set something equals instead. So that will save you a lot of time. Okay, moving on to legends. Again, unsurprisingly, you use them in 3D plots the exact same way you add legends to other plots. You just use the label keyword argument, and you can call ax.legend at the end. So going to import random, didn't need to do that as we've already imported it above, but just to be doubly sure. Going to set the random seed again to 1. That means that you will get the same results as me if you copy paste this code. So we set up our figure and axis as normal. We do ax.scatter for the first plot as normal. Nothing has changed. We just give it a label. And now what I'm going to do is randomly reorder the data. So these X, Y, and Z lists are here, and I just didn't want to manually rearrange them all. So what I thought would be cool is, pardon me, if I shuffle them. So a function from the random module, random.shuffle, basically it just takes a list and just changes the order of the elements. So just for data in XYZ, just shuffle it, and it shuffles them in place. So that means it actually modifies what X, Y, and Z point to, so you don't have to reassign it or anything. And then I'm just going to do ax.scatter XYZ and label a second plot. And if we call the legend, we set the location with the lock keyword argument to the upper left, and you'll see our legend is in the upper left, and that these points have been redistributed and plotted in different places. So, if you don't understand, or if you want to learn more about legends, check out this comprehensive guide to legends, which I also wrote just a few weeks ago. Also a YouTube video to help you along. There's a lot more you can do, but everything you can do with them in 3D plots is the same as 2D ones. So check out this article if you want more info. And note, so this is the first time we've run it. If we run it again, we're going to start getting different looking plots every single time we run it. And that's because we're just using XYZ, then we shuffle XYZ and plot XYZ. So now we're plotting the shuffled version, but then if we run it again, even though we've set the random seed, it doesn't matter because we're actually starting with different XYZ variables. So that's why I came back and reran this. I actually reran it prematurely, but anyway. Okay, let's move on to the final thing that we're going to cover in this video, and that is setting the background color. Already you can see here we're going to set the background to red and green. So we can use the set face color argument, method, but I'm sure you know by now that I much prefer using the set and then method and passing face color as a keyword argument. So in this color, I'm going to set, so these methods you'll see, they can be applied to a figure and also axis objects. So here we're just going to set up the figure, give it 8x6 again, just so there's more space to see. Add subplots the same, plotting's the same, and then we just do ax.set face color as red, and you'll see that all this area is the axis, and that's red. And then we're going to do figure.set face color equals G for green, and then just this tiny little bit of area around is green. So you may be thinking, why would I want to set the figure color to a particular color? Like, there's hardly any space here. This seems a bit silly, Adam. Well, fear not. I'll now show you why you may want to do that. And it's if you're going to use some subplots. So here, in this slightly convoluted example, I've colored all these axis objects, separate colors, but then the figure, the underlying part, is all pink. So this is one reason, one way you might want to do it. So to do this is really cool. We can actually set up our figure and axis objects in one function call, and that is the plt.subplots function. Again, if you're not sure how to use that, check out my article, link in there. I learned so much when I wrote this article. Absolutely incredible. This actually converted me to using figure and axis notation because it's just so powerful. And you'll see that this is actually, I've linked to it a bit earlier on, but this is like the full article. Well, so is this. Anyway, regardless. So we use plt.subplots. We set the number of rows we want to 2, number of columns to 2, because this is a 2x2 one. We're going to set the figure size to 8x6 just to give us a bit more room. And then the key move is this keyword argument subplot_kw, which stands for keywords. And this accepts a dictionary of values, and this gets passed to fig.add subplot. So you can see here I put projection equals 3D, and that is what we pass to add subplot. You don't need to add the 111 or whatever because we're creating a 2x2 grid here. Cool. Now I set up colors, just some random colors that I want to use. So red, green, yellow, and blue. And then we're going to iterate all of those colors and then all of the axis objects, because there are 4 axis objects. But this axis variable is actually a 2x2 NumPy matrix. So in order, but colors is a 1D list. So we need to iterate over them in the same order. And the way to do that is to flatten this matrix. So basically we're going to iterate for C ax in zip. That means we're iterating over colors and axis at the same time. Zip colors and axis dot flat. And flat basically returns an iterator of this NumPy array, but a 1D array so that we can iterate over them. Then for each of these axis objects, we're just going to plot the same graph, and then we'll set the face color to C, so that will change each time because we're using zip and a for loop. And then finally, we're going to set the face color of the figure to pink, and this is what we get. So really, really powerful. Something I would say I wouldn't recommend you'd randomly change the color of all your subplots and 3D plots, but it's cool to know, that you can even have 3D plots in subplots, and also that you can, set a figure to, set the color to whatever you want. One thing that I've just thought of as I was saying that is I wonder what happens if we plot this in an IPython window. What happens when it comes up? I imagine, oh wow, look at that. Look at that. Isn't that amazing? So each of these axis objects can be turned. So this would be a very powerful tool. You could take like 4 different shots of this as 4 different directions of it, and for your data analysis, and you could label each of these, and wow, so that's a really, really, really powerful tool. I literally just learned about that right now. So yeah, another reason why plotting it in these interactive windows is really helpful. Okay, that is it. We have reached the end of this article. You know all the basics you need to create 3D plots in Matplotlib. So what have we covered? So quickly, you learned the necessary imports you need, and also how to set up your figure and axis objects to be 3D, or rather just your axis objects. Your figures can't be 3D. You've looked at examples of line and scatter plots, and you can modify them by rotating them, adding axis labels, adding legends, and finally changing the background color. So there is loads to be learned about 3D plots, and I will almost certainly be doing more articles on them. And they do get quite complex and advanced, but obviously that's important if you're doing complex and advanced data analysis. So some examples are surface plots, wireframe plots, should I say, animating them and changing the aspect ratio. But unfortunately, they have to be left for another article. So if you thought, Adam, this video was awesome, absolutely love this, I love plotting, I love doing Python, I wish I could do it full time and actually make some money, but I don't know where do I start? Then I know exactly what you're going through. Literally in October 2019, so that's like coming up to 7 months ago now. I was also like that. I was learning data science, learning Python, and I wanted to make some money from it, but I didn't know how. I thought I had to get a full-time job. And then I stumbled across Thinkster and this webinar, which you can get to through this link, and bought the Thinkster. Chris, who is the creator of Thinkster, bought his course teaching you how to become a Python freelancer in 60 days or you get your money back. So you're earning at least $20 an hour in 60 days or your money back. Like, that is a crazy, crazy guarantee. This is literally, it's guaranteed. I love this so much. This is Chris here on the video. And you'll see that I actually love it so much that I have 2 testimonial videos. So I was earning $50 per hour within my first 2 months. And then also my second Second Testimonial video showed me earning $5,000 a month. So I really, really cannot recommend this enough. Chris has got a video here as well going through all the walkthrough material. It is incredibly high value, literally changed my life. And I would really strongly recommend you check it out if you are interested in going pro. So thank you so much for watching. I absolutely love doing these videos. I hope you enjoy them as well. If you have any questions, please post them in the comments and I will try to get back to you as quickly as possible. Though, and with that being said, until next time, stay safe in these like coronavirus times. Hope you are, isolating and your family as well. And I look forward to seeing you in the next video.